What's going on, everybody? Today's RRE episode is actually going to be kind of cool, I think, at least. We're going to talk about how to take a Python file, make it an executable, and then embed that executable within your existing malware. So I've got a very, very simple Python kind of proof of concept here. Essentially, it's just a wrapper around the request library to send one very, very simple request to my C2 server. And basically what we're going to do is we're going to use a library called Py2Exe to pretty much do exactly that. We're going to take a Python file, turn it into an executable. So let's go ahead and get started. Let me switch our scene over here. So we've got our very, very simple Python file. Like I said, all it really is doing is sending a GET request to this test API interface. And that API interface is going to answer with a JSON blob. So basically what we're going to do is we're going to turn this into an executable, and then we're going to embed that executable within the malware that we've already written, which is wicked cool because it kind of allows you to go ahead and write all of your malware within a much simpler language and then just wrap that in an executable so it can be run pretty much on any Windows system. So really not too much of a point in walking through this file in particular. Literally all it does is send one request to that API interface, but I will explain the other Python file here called setup.pi. So it's not there, it's here. So setup.pi is basically the configuration file that tells Py2Exe, which is the kind of the compiler that will take your Python file and turn it into an executable. Setup.pi is basically what tells it how to do that. So we are telling it to bundle the files up. That is a necessary step in order to be able to run it on a system that doesn't have Python installed, which is kind of what we want to do in the case of like malware, because we're going to assume that the victim does not have Python installed. So we're going to bundle it all together, and we are going to compress it. We are going to run it as a console application with only one script that we're worried about, which is embed.py. That's the one that I just showed you, the really simple request wrapper. And we are not going to zip it up. We're not worried about zipping it. So basically what you're going to do here is you're going to run Python setup.py py2exe. And that's going to use this setup.py script right here to compile our embed.py file right here. So when we run this, we're going to end up with a dist folder that's going to have a bunch of stuff in it. The only thing we're really worried about is right here, embed.exe. So that is our actual embedded executable file. So if we run this, we'll see a bunch of stuff popping up. It's running Py2Exe. And apparently it takes a little while to run. We get access denied. I think that's because it's open here. But we've already compiled it. So we've got embed.exe right here. I just saw it. Embed.exe is right here. And now we've got our executable. If we wanted to run this executable, I'll go ahead and pull up my C2 right here. So here's our C2. Looks like crap for some reason, but I'll go ahead and bounce it. So we're running our C2. If we went into our file system here, this is what we're looking for. And reveal in File Explorer. And now we can go ahead and run this. And it ran. If we look over here, we see that we've got one request to /hello. So it did, in fact, successfully run. Now, if you run this in the console, there's a bunch of weird error messages that I haven't quite figured out yet. But, it doesn't matter. It ran. It did what we wanted it to do. All right, so if we bounce over here to our actual malware, we've got two new functions to kind of go over. But before we worry about that, I'm going to explain kind of the high level of what we're going to be doing, and then I'll show it like actually in practice. So basically what we're wanting to do is we're wanting to embed this executable within our original executable, our original malware executable that this will compile down into. The reason why we want to do that is basically that's going to be how it carries it on. We could either have it as a second stage that's downloaded from the C2, which I'll probably cover a little bit later, or we could have it embedded within the original malware itself and essentially extracted somehow and then run somehow. So we're going to do it the very, very simple way. We're basically going to extract it as an embedded resource, which is what we're about to go through here in a second. And then we're going to write it out to an executable file to the actual like destination that the malware is being run from. So you can kind of see that a little bit here, but I'm going to go over the important stuff right now. So like I said, we're going to use an embedded resource in order to kind of carry this executable over into. So if we look over at our Solution Explorer, we've got two new files that you may not be as familiar with. We've got a resource.rc and a resource.h. So this resource.h, we'll go over that here in a second. The resource.rc is what's actually really important. So we're going to open this up with the C++ source code editor. Now, I did this the default way by like actually going into resource files, add, and then resource. And that adds just a bunch of junk that I don't necessarily understand and I don't think is like entirely necessary. You could probably get rid of like 90% of this and it still works fine. What we're really worried about is this right here. IDR underscore binary 1, then we've got RC data, and then we've got a file location. So if we look at this file location is actually the dist folder that we were just looking at right here. So it is going to take embed.exe out of this dist folder right here, and it's going to embed that file location right here. And this is actually accidental, but it's going to work out really, really well, because essentially what can happen now is every single time I recompile this embed.exe file, it's going to go to the same exact location, and then every time we recompile our malware, it's going to pull the newest version of that embed.exe. So what is this doing? Basically what this is doing is it's creating a macro right here called IDR underscore binary 1. This is the type, which is RC data. That is, I believe, an internal type to C++ that kind of represents an executable or a binary piece of data. And here, like I said, we've got the file location. So this is creating a mapping essentially between a file location and a macro right here. Then if we go over to resource.h, which is included right here, if we go over to resource.h, this is creating a mapping between IDR binary 1, which is the macro that we were just looking at over here. So we've got IDR binary 1, which is mapped to this file location, and in resource.h, IDR underscore binary 1 is mapped to a number, 101. Now, this number right here is the unique identifier that we're going to use to actually reference this piece of information, this binary data. So if we head over to our malware here, the first important line that we've got within our write embed function, which is going to be the function that extracts the embedded executable and writes it out to a file. If we look right here, we are making use of that 101 number right here. That 101 number is going to be how it actually figures out which resource that we're using. So this is a very important unique identifier that we find within resource.h that we can use later on in our file. So this is creating a handle to a resource. The hglobal right here is actually loading that resource in. I used a message box right here as kind of like a debugger, but it's not important. I'll actually go ahead and get rid of it now. And then we're going to read in the size of the resource and the buffer itself. Now we've got a void star buffer because essentially we want this to work in a way that it could technically work with any type of data. And we don't necessarily know if we want to read it in as a character string or as any other kind of string. So basically this is just a pointer to any type. So we're going to lock that resource right here using the hglobal variable here. We're going to create a file pointer that's empty at first and actually use that file pointer immediately to go ahead and open up a new binary file called embed_ret4.exe. So we're going to use this file pointer later on to write our buffer out to the file. So we're going to use that buffer. We're going to cast it as a character string buffer. We are going to use 1 for the actual size. That is 1 byte. We're going to write it out byte by byte. This exe size right here is what we read in up here, which is the size of the resource itself, and we're going to write it out using that file pointer. And then obviously we're going to close it. So again, fairly simple. Essentially all we're doing is we are pulling out the actual binary data from this resource that we've got embedded, and we're writing it out to its own file. Now up here, fairly simple stuff again. This is basically like copy pasted from MSDN. Basically, all it really does is actually executes that file itself. So we've got the file name hard coded here. That is the module name, and by default, create process looks within the running directory first. So we don't have to hard code the full like file location itself. We can just write the file name, and it will look within the original directory. And basically everything else here is null. We're not worried about command line arguments. We're not worried about inherited handles, anything like that. We do need a startup info and a process information structure because that's going to store some information that we might need later on. And then we've got a message box A that will basically pop up if it fails to actually create that process. So let's pull up our C2 again, and let's actually run this. All right, I'll clear it out just to kind of prove I'm not cheating here. And basically what we're looking for is we're looking for a couple of different API calls. So this is going to send a check-in request because I showed that in my last video, kind of how to write and read from registry. So it's going to show that check-in request, and it's going to show the hello request that comes from the actual embedded Python executable itself. So let's go over here. Let's go ahead and run it without debugging. I've got a couple of message boxes that are going to pop up. So like I said, right here, this is the error stuff that I don't really understand why it pops up. But if we look over at our C2, I believe, yep, we've already got that hello that hello call that was called with the Python executable, and then we're going to send our check-in request there. So it all works. Now this can be super useful. I mean, you can use this, I would imagine it would work fairly similarly if you created any kind of compiled executable, whether you write it in C, C++ and embedded it within another C, C++ piece of malware, or if you used Rust or anything else that creates some kind of executable, you could probably use it within here. You can also do it on non-executable files, so text files, if you wanted to embed those into it. I'm thinking like embedded scripts and things like that you could pull out and run on the command line. This is a very versatile method, and it's also one that I've read about a lot, actually within malware reverse engineering blogs as being something that actual threat actors use. So it's wicked cool, and I'm really glad that I learned a whole lot about it, and I hope you kind of gathered something from it as well. Take it easy. Peace.